My name is Anil Ravindranath. I'm the founder and CTO of Rapt.ai. It's glad to see that Chris introduced us already in one of his slides. You might have known what it could be. So the main idea, what we are going to talk about here is how can you use Agentic AI to manage your GPUs, or how can you use AI to do a GPU workload automation. I think this one, I'm sure everybody is familiar with. If you are intending to either manage or use the AI infrastructure, it's two things. That is, one is it's pretty complex, and the cost for you to run your AI projects in a given AI infrastructure is pretty. It's not good with economics, or it's high cost, right? So that everyone can relate to. So why is this a problem? Compared to a traditional workload, AI workloads in general, or AI model workloads, whatever you're running in, they have two characteristics, which is dynamic and unpredictable. So that's the nature of an AI workload. It could be because it's a continuous learning algorithm. Even when you're doing not just your training or tuning, even when you're doing inference also, because of a reasoning in there, it's kind of a continuous learning. It's kind of putting together a logic, and then it learns continuously, right? That's one of the reasons why there is dynamic unpredictability. The second reason is no two models are same. Basically, you can have a different different quantization, different batch sizes, or sequence length. You're running the same model in a different way, right? That results into a dynamic unpredictability of your workloads. The last one is based on your business workflows or your SLAs, right? You could be running a few models or something which is for the cost, or some for performance or production, or based on your priorities, right? That leads into a lot of dynamic unpredictability. That's the nature of the game that we are in with respect to the AI workloads. And the biggest challenge with all this is time is the money, right? So if you are a data scientist or an ML engineer who is running your AI models, not just running your AI models, you spend a lot of your time in tuning the infrastructure because you want to run it effectively in a shortest amount of time, right? As the models become more complex, your effort in provisioning the infrastructure or tuning the infrastructure becomes even more complex. And if you are an ops team or a platform or somebody running it, it's even more daunting because now the costs are pretty high for somebody to run your AI models, especially with new models coming in, reasoning and all. The more compute you need, it becomes more challenging for somebody to manage it, right? So the other big challenge is, imagine if you already have fine-tuned your model, trained your model, you're okay with your sizing and everything. Now comes a scenario wherein if you're running an inference, it's kind of a wild west wherein nobody knows what you're expecting, right? It's a lot of dynamic unpredictability that happens even at the inference because of the workload spikes and the requests. Now, if you look at a typical infrastructure, or especially the GPUs, right? It's hard to manage it because most of it is underutilized but over-provisioned. It's not that somebody wants to do it, but because of the nature of the workload, you end up being in this scenario. Right? It's pretty complex to kind of manage this infrastructure, and it directly affects, in some cases, the training and tuning the CapEx, but in inferences, managing the OpEx becomes even more complex. Here is an example of what we are trying to show here, right? A small change in the model results in a big change in a GPU utilization. So as you can see here, we just changed a sequence length of a model from whatever input sequence length you're giving. You change a bit in there, so that results into a huge utilization in the GPU, which somebody has to go and monitor and look into that. It's pretty hard, right? That's what we are trying to show here, right? And the other big misleading factor in here is everybody thinks that the GPUs are already maxed out, right? As you can see in one of the things here, you can see the utilization is higher, but in reality it is not, because underneath inside the GPU, it is not really fully utilized. Basically, you're not maximizing your GPUs. That's where the costs go up, and as things become more and more dynamic and unpredictable, it's hard to manage this kind of an infrastructure. See here is an example wherein a simple the smallest change in the utilization directly affects your OpEx or your revenues, right? So like a 5% drop in utilization results in hundreds of thousands of dollars. If you were to manage, as an example here, a $2 million that if you're managing, or your revenue, you're expecting it to be $2 million per month, a 5% drop in utilization of your GPU results in a lower economics, and then your OpEx certainly increases just because of that, right? And especially with the new models coming in, especially the reasoning, more tokens, more compute, this kind of becomes a pretty big challenge for anybody to manage the infrastructure, or anybody running their AI models. So why is this problem, right? To start with, like as I said, everybody is looking at like the way how you used to manage or run your infrastructure. It is more reactive, right? It's more of a manual way of doing things, which is kind of, let me go and tweak here and there. Or the best I can do is I can just do a simple resource sharing, like a time sharing of GPU infrastructure, and I can get away with this over provisioning underutilization. That's what everybody think or does, which is more a reactive way of doing things. But ideally, it has to be more proactive, which is, let me go and understand the insights of what the workload looks like, or the model looks like, right? What is it being targeted to, right? What GPU or what infrastructure it is being targeted to? What is the behavior of that, right? That's one thing that as a modern infrastructure you need to think. The second one is, based on that, can I go and dynamically optimize? It could be a model or it could be a resource, right? That's what you can do it. And the last one is, obviously it has to be dynamic and unpredictable friendliness, especially if you're running more and more inference and then reasoning models moving forward, right? And that's exactly what Rapt.ai brings to the table. And the big advantage what you get when you're proactively doing something is you're continuously monitoring and proactively doing it. You don't need a human in the loop, right? Everything works automatically. So it's kind of a three-pronged approach is what you can think as an automation. One is observe and recommend. So let me go and observe the AI models transparently without any user inputs. Can I go and observe an AI model or AI workload? That is one. And based on that, can I go and recommend the infrastructure based on that? A simple example is, hey, I'm running, this is my tokens, or this is my batch size. So what is the recommendation of a GPU for that, right? What should be the sizing of that, right? So that is what a observe and recommend module would do it. The second one is an optimization. So based on that, since we in real time we analyze and recommend, can we go and optimize the model and also the resources in real time, right? That's a lowest granularity, can I go and do it? And the last one is, since we do this, so why not we take the advantage of our observe and recommend to go and orchestrate it across the full cluster in a cloud or any infrastructure, right? So can I just share the GPUs across, right? Fractionalize or share, but with the intelligence, without any human in the loop. That's a main idea here. And can I do this across not just one set of GPU or GPU model? Can I do it across the board, right? Can I apply it for like, NVIDIA GPUs, AMD GPUs, and also can I work with any new accelerator or new chip that is coming in the market, right? I can just apply this framework on the platform, and this can be completely agentic. So you are an ops or a platform guy, so you can just use a Slack or a dashboard for you to go and apply use the agent or the observer agent in this case to get the information. If you are a data scientist or ML engineer or anybody production you're running it, all you have to do is input the model recipe, and then it's a multi-agent system wherein there is a recommendation agent, there is a observability observer agent, there is an optimization agent, and then orchestration agent. All of them work together autonomously so that you don't have to worry about it, whether you're a platform guy or a data scientist or an ML engineer. So it's kind of an agentic approach to do the things. So how it works is, if you are a ML engineer who's running it, all you have to do is that input the model recipe, and then you set your SLAs for cost of performance based on your needs, and then all these 4 agents which are running below in a platform, they work together, and then it kind of kind of make it happen without any user intervention. That's a biggest takeaway, right? That's what we want it to be managed. And if you're an ops or an IT, like as I said, all you have to do is that input your either through a Slack or through any of your like a pager duty or through a dashboard. You get all the information of how the whole infrastructure is being used. So the biggest benefit what you get is, so if you look at this two graphical way of looking into things, is in one side you have same resources which are either over provisioned and underutilized. That's exactly what the scenario currently is. Now it can have, based on the model or model size, the model characteristics, you can have the infrastructure dynamically provisioned using this framework of autonomously monitoring, optimizing, and orchestrating. So this kind of becomes more workload based, wherein like as an example is, let's pick, you are running two models of same in nature, one with a sequence length of input tokens 600 and one with 800, or you have a batch size of 32 or 64, right? You're running the same model in two different ways. Now, what it is trying to tell here is, so based on that, your infrastructure is going to be allocated and utilized rather than being over provisioned or underutilized. So it's kind of a dynamic workload-based approach is what it will be. So you get more, you can run more models, okay, with less cost. And the other one is based on the model allocation. That's the biggest thing, because typically everything is more of a static way of doing things. Here it becomes more dynamic, and based on the workload characteristics, it's going to allocate the resources based on the model. And here is kind of I would say a money slide. So with this approach, what you get is the true utilization of a GPU infrastructure, right? As we saw in the previous slide, your GPU utilization might be higher, but in reality, the actual cores or the ASMs or compute units or the memory that you are using, in reality, they are not fully utilized, right? So with this approach, with a continuous observation, optimization, and orchestration, what you get is the true utilization to maximize the infrastructure and take care of the costs, right? That's exactly what you are supposed to do moving forward, especially with the newer models that are coming in the market. And also, the biggest gain is that no human in the loop, right? So you don't have to worry about any intervention as to guesswork or estimations. You don't have to do it, because in some cases you cannot even do it, right? In some cases you can, but most of the cases you cannot because of the nature what, especially for inference workloads and all, or the tokens that you're generating, there is no way you can go and guesswork or estimate the infrastructure what you need, right? So with this approach, you can continuously keep it running without any user intervention. And the other is, since it kind of understands the model which is being routed to, let's say, to an AMD GPU or an AMD or an NVIDIA GPU, it understands the characteristics and what is the memory, what is the cores of each of the GPUs, and it can apply the same platform or same logic across a heterogeneous infrastructure, right? So that's another big benefit that you can use across any compute or any cloud. Right? Yeah, so that's about it. So if you want to just want to know more about what we do, two things. One is we do have a raffle that we are running, wherein if you want to learn more, you can always sign up. And also we do have a table wherein you can come and talk to us. Okay? And you can find me at this email or over LinkedIn. Yep. Thanks.